sketch the function f of x is equal to negative 2 over x squared minus 4. This is a rational function, and the first thing that we have to find is the vertical asymptote. So for the vertical asymptotes, we simply equate the denominator to 0. So the x squared minus 4, we equate it to 0, and of course this is going to give us x minus 2 and x plus 2 being equal to 0. If we can't factorize, we can even use the quadratic formula. So that is going to give us x being 2 and x being equal to negative 2. Now, as long as this function, we have got a number on top and the denominator has got a letter. This one, or let me say, as long as the function has got the denominator having a higher power than the numerator, then the horizontal asymptote is always going to be at y is equal to 0. So in this case, we are able now to sketch like this. Now, one thing that I'm going to do is, looking at the way the function is, what I'm going to do, I equated this denominator to 0, and I found these factors positive 2 and negative 2. So what I'm going to do is I'm going to write a table of values. I've got a negative 2 and a positive 2. This is simply a number line, and then I'll put the factors which I equated to 0. That was x minus 2 and also x plus 2. Now these two factors are multiplying, so I'm more interested in the product. So when I equated x minus 2 to 0, I found positive 2. If I use any number of value of x greater than positive 2 and put it in this function, it's going to give me a positive value. Immediately I cross the 2, it will give me negative. When I equated x plus 2 to 0, it gave me negative 2. If I use anything above negative 2, like a negative 1, it will give me positive. Immediately I cross a negative 2, it will give me negative in this factor. So negative by negative is positive, positive by negative is negative, positive by positive is positive. So I'm going to put this in my asymptotes. I've got positive 2 and also negative 2. We also know that we have got another asymptote which is horizontal, and that is just along the x, because y is equal to 0 is basically the x-axis. Now then we are going to look at the factors that we have found. Don't forget about this negative. So what this means is, for values of x less than negative 2, the function is supposed to be positive, and positive just means above the x-axis, meaning function, as we are talking about values of x greater than negative 2, so supposed to be above the x-axis, which is in this region. Now we always follow the asymptote, so I'm supposed to be following the asymptote going up, and I'm supposed to be following the asymptote going this direction, and simply connect these two. Now because this is a negative, we are going to reverse this, because it's going to be this negative divided by a positive, and the answer is going to be positive, meaning that our function is going to fall in this quadrant. So for values of x less than negative 2, the function is going to be down, and then between negative 2 and 2, it was supposed to be negative, but negative over this negative is going to give us a positive. So between negative 2 and positive 2, the function is supposed to be positive, okay, meaning that it's supposed to be above the x-axis. So we always follow the asymptote, supposed to be going like that and also like this. So we simply connect this side, and then above 2 it was supposed to be positive, but because of the negative which is here, we are going to drop it in this region. And so one thing that we should be able to do is we need to determine what the turning point of the graph is going to be at that point. So I'm able to see it is going to give us a 1 over 2. So what we do is we just use derivatives. We should differentiate this. We know the derivative at the turning point is supposed to give us 0, and then we equate the derivative to 0. So the domain of this function, we can see the x values. The smallest we can have is negative infinity, and then we are pausing at negative 2. We are not including negative 2. Then from negative 2 we are going to positive 2, and then from positive 2 we are going to positive infinity. And then for the range of this function, the smallest we can have down is negative infinity, and then we are going all the way up to 0, but we are not including it. And then we are moving from the turning point here, okay, so whatsoever the turning point, we are going to include it up to infinity. So the turning point, we just use calculus there.